Hey, this is Mr. Coker with Geometry Lesson 1-2, Part 2 of Reflections. So, previously I talked about reflecting a point over the x-axis and y-axis, and now I'm going to talk about three things: reflecting over the line y equals x, reflecting over the line y equals negative x, and reflecting over an arbitrary line. For the first two of these, I have the rules on the board. So if you want to write those down, this would be a good time for it. But the rule probably doesn't mean much to you unless you remember what y equals x means and y equals negative x. So both of these are linear equations written in slope-intercept form. A linear equation tells you the y-intercept and the slope of a line. The y-intercept is determined by the constant. Well, we don't have a number listed. We don't see a constant, so we know that number is 0. That means our y-intercept is 0. Our slope is determined by the coefficient of x. The coefficient being the number right in front of the x, touching the x. Well, again, we don't see a number. We don't see a coefficient. And when we don't see a coefficient, we assume that number is 1. That tells us the slope is 1. To find slope, you're going to go up 1 over 1 to find a slope of 1. You can go up 1 and do the right one, and you can go down 1 and do the left one. Both work. I know my line isn't perfect looking, but that's okay. I will make a video in the future about how to find slope. So in this case, our rule says that we flip x, y, which in this case is 2, 1. That's our x and our y. And we flip that and turn it into yx, which just means that we flip the order of the two numbers. And now we have 1, 2. So I'm going to graph 1, 2 on the coordinate plane. I go over 1 and up 2. And now I have 1, 2. And you can see, hopefully, how that's reflected. It's equidistant from the line on both sides. Now to find y equals negative x, we're going to do the same thing, flip the numbers, but because it's a negative x, now we're going to flip the signs on both numbers. So when we graph y equals negative x, again, we have no constant, so our constant is still 0, and that means that y-intercept is still 0. The coefficient of x is now negative 1, because that's what the negative sign tells us. It tells us that we have a coefficient of negative 1, therefore we have a slope of negative 1. I'll talk again about slope in the future. For right now, for our purposes, when we're finding slope, if it's negative, we want it to be up 1, left 1, or we could do down 1, right 1. This is the line y equals negative x. So the rule now tells us that instead of doing 1, 2, we do negative 1, negative 2. So I'm going to plot that point on the coordinate plane. I go negative 1, negative 2. And you can see that it should be equidistant, meaning equal distances from that line on both sides. And that's the rule. It's a very easy rule once you memorize it. Fortunately, the last thing I'm going to talk about is actually even easier. There's no rule for me to give you, but you'll always have a graph if this is the case. So let's assume that we have And I'll leave this up and draw a new coordinate plane. And I'm going to draw a line going down x equals 1. This line is x equals 1, and I'm going to put a point again at 2, 1, just to stay consistent. So I'm going to now reflect over x equals 1. So when we have a line like this, all we're going to do is count the distance from the line to our point. We go right 1 to reflect over, to get to 2, 1. So when we reflect, we're now going to go left 1. That's how we reflect. So we went from going over 1 to the right to now going over 1 to the left. I just look at where it is on the coordinate plane. We have 0, 2. And that is our reflected point. Thanks for watching, and have a nice day.